Now let's start. This question was solved last year. 1 to 50 was solved last year, and this year I would like to extend the question to 80 question. So I'm going to start with number 51. So let's see how to solve this question, number 51. And the first question is, the average temperature of a perfect gas is proportional to the average. Let's look at the option. The option we have here is A, pressure, B, velocity, C, kinetic energy, and D, potential energy. The correct answer here is the average kinetic energy. C is the correct answer. Now you can get this from kinetic theory of matter. Now one of the kinetic theory of matter, which is what postulate of matter, is that the absolute temperature of a perfect gas is proportional to the average kinetic energy of the particles or the atom or molecules of those gases. And let's look at the next question. The next question over here is, when the bottom tip of a vibrating tuning fork is held in contact with a wooden box, a louder sound is heard. The phenomenon is known as A, reverberation, B, echo, C, resonance, and D, pitch. Now the correct answer here is resonance. What is resonance? The correct answer is C. Now resonance is just a natural phenomenon that occurs when a body is vibrating and it sets another body into vibration. So if a body is vibrating and is vibrating at a natural frequency of another body, automatically is going to set that body into motion. That body will also start vibrating. So the correct answer here is C. If you have a tuning fork and you bring it close to a table, you hear a louder sound. Now that is when resonance occurs. The next question, number 53. Which of the following has a negligible mass? A, proton, B, gamma ray, C, alpha particles, and D, beta particles. Now out of all these, gamma rays has the negligible mass. Don't forget that proton has mass. Gamma ray, when a radioactive element is disintegrating to form a radiation, and that radiation is mainly gamma ray, that radioactive element is not going to lose its mass number, its mass or atomic mass, neither is it going to lose its atomic number. So it's not going to lose its atomic mass and atomic number. So gamma ray has negligible mass compared to helium particles. Helium is that of alpha, and electron, neutron, positron, they are particles of what? Of beta particles. They are part of beta radiation. So out of all this, gamma ray has negligible mass, or gamma ray has negligible mass. Let's look at number 54. Now, under what condition are cathode ray produced in a discharge tube? Under what condition are cathode ray produced in a discharge tube? A, we have high pressure and low voltage. B, low pressure and high voltage. C, low pressure and low voltage. D, high pressure and high voltage. Let me quickly explain this question for you. Now, in a discharge tube, an experiment was performed. This experiment was performed by J.J. Thomson. Now, in that experiment, he was able to know the charge to mass ratio of particles, of elements, of gas. So he was able to discover that, he was able to discover electron. He discovered that there is a ray that is being produced, which is known as cathode ray, and this ray has a negative charge. It's going to be deflected towards the positive side of electric field. So in that experiment, he was able to deduce he was able to get some ideology, was able to get some things from that experiment. And while he was performing the experiment, he did it at a certain condition. Now, what is the condition? In cathode ray, in the production of cathode ray in discharge tube, Now the gas must be when the current is being supplied, or the voltage must so be high. Example of cathode ray tube is the olden days television, olden days monitor. Now the currents at the base of that CRT, cathode ray tube, the current is, and the voltage is so high because there is a coil at the back of those cathode ray tube. So in order to produce high voltage, now the experiment is being performed while we have high voltage and low pressure. So we have high voltage and low pressure. B is the answer. Let's move to the next question. Which of the following principle or laws determine the direction of induced current in a conducting loop of wire due to a changing magnetic flux? In the law of electromagnetic induction, we have two basic laws. The first one is Faraday's law of electromagnetic induction, which states that current, or there will be an induced EMF when its conductor, when there is change in the magnetic flux. So a change in the magnetic flux will lead to generation of a current, an induced EMF. Now Faraday's law of electromagnetic induction is saying that, and it's saying that the current is directly proportional to the rate of change of magnetic flux. There is another law that is talking about the direction of the generated EMF or induced EMF. Now that law is known as Lenz's law. So we state that an induced EMF will act in a way to oppose the motion that is producing it. So that Lenz's law is also is as a result of a law of conservation of energy. You can see any question like that as well. It's also is as a result of law of conservation of energy, and this law is talking about the direction of the induced EMF. So it's going to act in opposite direction. So the correct answer is C, Lenz's law. The next question: which of the following devices uses an electromagnetic field to operate? I, light bulb; II, electric motor; III, radar; IV, transformer. Now let's look at all these devices. Now we have light bulb. Light bulb is an electrical devices. Now 2 is an electromagnetic device, which is electric motor. Electric motor is going to have a coil. A coil is generating an electromagnetic field. It's generating magnetic field. Coil is electromagnet, so it's going to generate electromagnetic field. Then we have radar. Radar is a communication system that is being used in airports. A radar is part of electromagnetic wave. Radar is part of radio wave. So it is not electromagnetic. It's not electromagnetic induction. It's not as a result of electromagnetic induction. It's electromagnetic wave. The communication system in the airport, when aeroplane is about to leave. So that communication system in the airport is being done, and the name is radar. Is under electromagnetic field. Electromagnetic wave, under radio wave. Now transformer also contains coils. So it's a device that is used to step up or step down electric voltage. So out of all this one uses electromagnetic induction to create motion. This one it uses induction to produce and induce EMF at the secondary coil, and that EMF is directly proportional to the number of windings. So in a primary transformer, we have primary transformer and secondary transformer. In primary transformer, we have step up transformer and step down transformer. In step up transformer, the secondary winding will be higher than the primary winding. So also the voltage at the secondary coil will be higher than the voltage in the primary coil. The same thing goes with step down transformer. The secondary coil will be lower than the primary coil. So the voltage at the output voltage at the secondary coil will be lower than the primary coil. So the correct answer is II and IV. II and IV, that's D. D is the correct answer. Let's quickly move to the next question. Now to the next question, an interesting and simple question, which I believe most of you used to be afraid of: calculation. Let's see how to solve it. An object with a mass of 5 kilograms is moving with a velocity of 8 meters per second. It experiences a constant force of 40 Newton in the same direction as its motion for 4 seconds. What will be the final velocity of the object after this time period? So I want you to look at this question. If you can screenshot it, you can screenshot it. Now let's see how to solve it. To solve any question, you write the parameters out. Let's go. Solution. So we were given that we have the mass as 5 kilograms in the question. We have the initial velocity, which is 40 meters per second. We also have the force, 40 Newton. We have the time taken, which is what? 4 seconds. Now the final velocity, we are asked to find the final velocity, which is unknown. Now let's see how to solve it. Newton's second law of motion is what we are going to use to solve this question. And what is can we state Newton's second law of motion? Is very simple. It states that the applied or impressed force on an object is directly proportional to rate of change of the momentum. Now it is the momentum product of mass and velocity. So that is what we have here, over here. Now force is equals to m open bracket final velocity minus initial velocity divided by time. So if you want to use calculus, Newton's second law of motion is mdv over dt. So d means change. Now this same formula is this. If you use m to expand this guy, you get this over t. That's Newton's second law of motion. That's what we are going to use to solve this question. Since we know mass, we know initial velocity, we already know our force. Our force is here. We know our force. This is the force over here, and this is our force. So we know our time. So what we are left to do now is we need to find our velocity. Now, if you cross multiply this guy, when you cross multiply this guy, you are going to get Ft is equals to mv minus mu. So as usual, there is 2 topics you need to know. There is let's say 4 topics in mathematics that you should need to know very well if you want to solve questions very fast in physics for your Jamb. Linear equation, subject of the formula, variation and fraction, variation, linear equation, subject of the formula, followed by ratio, rate and proportion. It's going to help you a lot. If you don't know it, go and know it. Now mv, make it subject of formula. Your mv, we are going to have what? Ft plus mu. Don't forget, we want to find the value of v. Now make v final subject of formula. Divide both sides by what? Divide this guy by m and divide all this by m. So we have what we have here. This guy v is equals to what? Ft plus mu over m. Now you can still go further if you like. Divide this ft by m. You have ft over m. Don't forget, you are going to divide this one by m again, plus mu divided by m. So you are left with what? Ft over m plus u. Now substitute what we have here inside your formula. So we have our mass, our force, 40 times 4, which is our what? Our time, divided by what? Divided by 5, which is the mass in the question, plus what is our initial velocity? Our initial velocity, sorry about that, while typing this I made mistake. Our initial velocity is supposed to, this guy is supposed to be, this u that is here is supposed to be 40, while this one is supposed to be 40. Then we have 40 multiplied by 4 divided by 5. 40 multiplied by 4 divided by 5, we have 32 plus 40. So our final answer will be 40 plus 32, that's 72 meter per second. Our final answer will be 72 meter per second, not 40 meter per second. So our initial velocity is 40 meter per second. Let's go back to the question to confirm that. So in the question, our initial velocity is 8. Sorry about that. So the solution is correct. I'm sorry about that. Now the initial velocity here is supposed to be 8. So in the solution is correct. 40 times 4 divided by 5 plus 8. So 32 plus 8. So our answer will be what? 40 meter per second square. Let's move to the next question. A metal rod has a length of 2 meters and a coefficient of linear expansivity 1.2 times 10 raised to the power minus 5 per Kelvin. If the temperature of the rod is increased by 56 degrees Celsius, what will be the new length of the rod? This is one of the topic in SS1, which is expansivity. In the question, a metal rod has a length, that is the original length, initial length, and the coefficient of linear expansivity alpha. This is the coefficient of linear expansivity here. This is L1 initial length. If the temperature of the rod is increased by 56 degrees Celsius. Now let's get this understanding, because we need this temperature, increase in temperature knowledge in some calculation in physics, not only expansivity. Increase means change in temperature, theta 2 minus theta 1 or T2 minus theta 1. When you see increase, rise by, increase by, decrease by, it means change in temperature. Initial temperature, final temperature minus initial temperature. So the question now say, what will be the new length? L2. So let's look at the solution, the parameters. We are given the initial length L1 2 meter, coefficient of linear expansivity, which is alpha 1.2 times 10 raised to the power minus 5 per Kelvin. Now go back to coefficient of linear expansivity. Coefficient of linear expansivity, this is the formula. Alpha is equals to L2 minus L1 over L1 change in theta, change in temperature, which is the same thing as what? L2 minus L1 over L1 theta 2 minus theta 1. Change in theta means change in temperature. And in the question, we were given change in temperature. Let's go back to the question. Our change in temperature is 56 degrees Celsius. So let's see how to solve that. In the question, we are asked to find the what? The final. Let's go back to the question. We want to find the new length, which is L2. This is the formula we are using. Now let's try to make L2 solve the formula. Cross multiply. When you cross multiply, you can pick these two formulas. You can pick this formula, or we pick this formula. This and this guy. Let me clean that. So let me use my pointer instead of pen. Now we can use this formula together, or this one and this one. So anyone you use is still the same thing. Now let's make L2 solve the formula. If you cross multiply, you have alpha. I want to pick these two guys. Alpha L1 change in temperature is equals to L2 minus L1. Now let's go. The next one, L2 will now be what? L1. This L1 you transfer it to this side. L1 plus, that's typographical error. This one's supposed to be plus. Now L2 will be what? L1 plus alpha L1 change in temperature. Then go ahead and substitute your value. We are given everything in the question. So our L1 is 2 plus 1.2, which is alpha, times 10 raised to the power minus 5 times 2, which is our what? Our L1 times 56 change in temperature. If you solve that, if you multiply all these guys together, we are going to get 0.00134 plus 2. So our final answer is 2.00134. So let's go 2.00134. So this is our correct answer. I know most of you are always afraid of calculation, and I prefer calculation because with calculation, this is our correct answer. With calculation, you are rest assured that you are getting your answer. Unless you are so knowledgeable, that is why you can be getting some theory question that are not calculation in physics. In fact, calculation should be a bonus. And let's move to the next question. An object is weighed at different locations on the earth. What will be the right observation? Let's look at the option. Mass is constant while weight varies. B. Weight is constant while mass varies. C. Weight and mass varies. Then D. Weight and mass are constant. This one is so simple. We know that mass is constant. Mass is the amount of matters present in a body. It's the total sum of matter in a body. So, and what is matter? Anything that has weight and occupies space. Your mass is everything that is made up of, that you are made up of. That's your mass. In some textbooks, you see them writing mass is also dry weight. We are not going that way. Now, mass is the quantity of matter in a body, in an object. So that is mass. And mass is always constant. Mass is what? Is always constant. Mass is a scalar quantity. It doesn't have direction. Your mass doesn't have direction. Mass is also measured in kilogram. The device that is used to measure mass is chemical balance. Chemical balance is used to measure mass. SI unit for mass is kilogram. Mass is constant. It doesn't change. If you measure your mass on the earth is still the same thing as your mass on Jupiter. If you travel to Jupiter or you travel to the moon, your mass is constant. While weight is as a result of gravity, gravitational force, gravitational pull experienced by body. Weight is measured by spring balance. Weight is also measured by lever balance, lever balance, spring balance, beam balance. They are all used to measure weight. Why chemical balance is used for mass. So the correct answer is mass is constant. Weight is also a vector quantity. It has a direction and it has magnitude. It has size and has direction. The direction of weight is downward because gravitational force is pushing every object downward to the center of the earth. So the correct answer here is mass is constant while weight varies. A is the correct answer. Let's move to the next question. When light wave encounter a surface and bounce back in various directions, what is the phenomenon called? Now we have refraction. B, we have diffusion. C, we have diffraction. D, we have reflection. Here, there is a confusion in this question, and I'm going to tell you. Now, whenever there is change in the direction of wave, don't forget light is a wave. Light wave, whenever there is a change in direction as a result of hitting an obstacle, if a wave is traveling, example light wave, and it encounter an obstacle, there will be a change in the direction. That change in direction is known as reflection. Now, reflection of light, we have two reflection of light. A reflection of light, when there is a smooth surface, the light will be reflected, and every light is a particle and it's also a wave. Now, every wave or every particles of that light will move in the same direction, will be reflected in the same direction, will travel in the same direction if there is reflection on a smooth surface. But if there is no reflection on a smooth surface, we have irregular reflection that we also call what? Diffusion. So, but the perfect answer here is reflection. The perfect answer here is what? Reflection. So, reflection on irregular surface is what we call diffusion. So, the answer is reflection. So, the image in pinhole camera is. The next question. The image in a pinhole camera is A. Virtual and formed by dispersion. B. Inverted and formed by the light from each point traveling in a straight line. C. Erect and gets sharper as the hole becomes larger. Then D. Erect and formed by refraction through a lens. The image in a pinhole camera. Let me quickly explain pinhole camera. Now, pinhole camera, the image that is formed on pinhole camera is real, not virtual. What is a real image? Any image that is formed on a screen and is formed as a result of actual intersection of rays of light. Image are formed by intersection of rays of light. Now, then the actual intersection, when there is intersection of the rays of light, if you trace the rays of light as they progress and they intersect to form image, we call that image real image. Automatically those images will be formed on a screen. So image formed by a pinhole camera is real image. Now any image that is formed on a pinhole camera, which we call inverted. Image of a pinhole camera will also be inverted. Now let's go. Image of a pinhole camera is not erect. It's only image in a plane mirror. Now the answer is, now let's go on. Inverted and formed by light from each point traveling in a straight line. So that's B is the correct answer. Now I want us to see some options here. The right erect and get sharper as the O becomes larger. No. Number one, the two statements that is combined to form a single statement is not correct. Image of a pinhole camera is not erect. Now it doesn't get sharper as the O becomes larger. In fact, as the O increases, it becomes blur. It's not sharper, it becomes blur. Now pinhole camera doesn't have a lens. Look at this option. Erect and formed by refraction through lens. No. Virtual. No. Formed by dispersion. No. Let's look at this question. Two objects A and B are placed in a closed container. After a while, the temperature of both objects becomes the same. Which of the following statements must be true? A is thermally stable than B. B, A and B are not thermally stable. C, A and B are not in thermal equilibrium. D, A and B are in thermal equilibrium. This one is straightforward. Now we have two objects at different temperature. They are placed in a closed container. After a while, we observe that the temperature are the same. It's very simple. The same phenomenon is what happens if you have cold water and hot water. You mix them together. The cold water inside that hot water, we have the same temperature with what? The hot water inside cold water. So they assume a equilibrium temperature. So which means they are thermally equilibrium. There is a law under law of thermodynamics, and that's supposed to be zeroth. Is it zeroth law of thermodynamics or third law? That should be third law of thermodynamics. Third law of thermodynamics. Now we state that when two objects are in different temperature and they come together, they are going to have a uniform temperature. That's what that law is saying. Now this one is what? A and B are in thermal equilibrium. A and B are what? In thermal equilibrium. The next question. A ray of light passes through the optical center of a converging lens. What happens to the ray of light after it passes through the lens? Now, a ray of light passes through the optical center of a converging lens. Now, if a ray of light is passing through the center of a converging lens, now after the refraction, the ray is not going to be refracted. So if it's not going to be deviated, that's what I want to say. That ray will just pass straight because it's passing through the optical center. So let's do it. Is refracted? No. It is reflected? No. It doesn't refracted and it goes undeviated. This is the correct answer. So any ray that is passing through the optical center. There is one question here again that I'm going to solve, which I will explain everything. There is calculation, but I'm going to explain it. There's still one question here. Now, it is refracted and deviated. No, the answer is it doesn't refracted and it goes undeviated. 64. Let's look at this question. An RLC circuit in series has a resistance of 10 ohms, an inductance of 200 millihenry, and a capacitance of 10 microfarad. What is the impedance of the circuit at a frequency of 100 Hz? This is simple AC circuit and it's very simple. Let's see how to solve it. We are given the resistance R, 10 ohms. We are given the inductance 200 millihenry, and then we are given the capacitance 10 microfarad. So also we are given the frequency. So this is simple AC circuit. Every AC circuit is being generated at a certain frequency. The NEPA light that we are using, the power that we are using, that one is 50 Hertz Hz. And let's go. Solution. These are the parameters that we are given. In the question, they gave us R, the resistance, 10 ohms, standard unit, so we don't need to do any conversion. Capacitance, they gave us as 10 microfarad. The first thing which you need to learn is the meaning of micro, milli, kilo, all this symbol. Micro means 10 raised to the power minus 6. So if you put it there back, your capacitance will be what? 10 times 10 raised to the power minus 6 farad. Now, inductance is measured in Henry. The unit of inductance is Henry. Please know it. They asked them last year. It was asked last year, Jamb. The unit of inductance is Henry. H, capital letter H. Now 200 millihenry. Milli is 10 raised to the power minus 3. So if you put 10 raised to the power minus 3, which is also 0.001, if you put it here and multiply it by 200, you get 0.2 Henry. Our frequency is 100 Hertz. It's already in SI unit, so we don't need to do any conversion. So let's go. This is our diagram for the question. You don't need this diagram. I just want to use it to explain, because question like that doesn't come straightforward. They can just draw a diagram like this and they ask you to find the impedance, the reactance, anything they can ask you. Now this symbol here is a coil and is inductor. Inductor is a device that stores electric charges in magnetic field. It's just like capacitor. Inductor uses current. Now what is a capacitor? Capacitor is a device that stores electric charges in electric field. And this is not a capacitor. Let me clean that. What I just touched is a resistor. What I touch is resistor. Now this guy over here is our resistor. Resistor is the device that opposes the flow of current. It resists the flow of current. Now this is capacitor. Look at the symbol. Look at this symbol. It's capacitor. Parallel plate capacitor. Capacitor is a device that stores electric charges in electric field. Now this guy it has a resistance, abi? The resistance is opposition to the flow of current. Now this inductor as well also offers a resistance. No matter, even if any material, any conductor, be it acid, be it electrolyte, be it metal, even though they allow electricity to pass through them, they also offer some kind of resistance. So this inductor, it offers a resistance, and that resistance is known as inductive reactance. This capacitor, it also offers a resistance, and that resistance is known as capacitive reactance. They have formula. Let's go. Now XL, which is the opposition to the flow of current offered by inductor, capacity or inductive reactance, the formula is 2 pi FL. So if you put it there, 2 pi is 22/7, the frequency is 100, the inductance is 0.2, and you multiply all these together, you get this. This one is measured in ohms. I omit the units. 125.670 ohms. That is resistance offered by inductor. Now let's move to another device again, which is capacitor. Capacitor also have capacitive reactance, opposition to the flow of current offered by a capacitor. The formula is almost the same thing like this, but the only difference is reciprocal. 1/2 pi FC. 1/2 pi. This is our F 100. This is our 1/2 pi F. This is our C, 10 times 10 raised to the power minus 6. Now if you solve that, you get 1.159.11128. That is. So after you have gotten the value, after you have solved the value of the capacitive reactance, which is 159.198 ohms. The next thing is to find the impedance. I've explained earlier on that in AC circuit we have RL circuit, we have RC circuit, and then we have RLC. Now in secondary school you will be taught simple AC circuit, and those circuits are in series connection. For instance, if you look at this diagram, you see that the inductor, the capacitor, and then this resistor, they are all connected in series. So we have series AC circuit and then we have parallel AC circuit. So the idea of but what we will be looking at is series. Inductive reactance is opposition to the flow of current offered by inductor. Capacitive reactance is the opposition to the flow of current offered by what? A capacitor, and then we've calculated it. Now if you now have combination of resistor and inductor, or resistor and capacitor, or capacitor, resistor and inductor, that is when you have the next opposition to the flow of current, which is going to be our impedance. So this Z is impedance. Now impedance is also square root of R squared plus XL minus XC squared. So go ahead and find it. Now putting all this in your formula, so we are going to have 10 square coming from our resistor 1.25.670, which is our what? Our inductive reactance minus our capacitive reactance. If you square it, you are going to get 10 square plus. Finding this difference, you get this, and you find the square. After you solve that, we are going to get square root of 100 plus 1113.438. We add the two together and then you find the square root. You are going to get 34.8. Now nobody will give you question as complex as it's not even complex. They will give you values that you can easily solve. They will give you, at the end of the day, the impedance is going to be a perfect square. The square root is going to be a perfect square number, so that you won't get points. In fact, you don't even need the calculator that Jamb is going to provide you for solving your physics question. So let's move to the next question. The pressure at any point in a fluid at rest depends only on A, depth and density, B, mass and volume, C, quantity and the surface area, D, surface area and viscosity. So surface area and viscosity. Before we choose the correct option here, let me quickly explain something for you, which is hydrostatics. Now we have hydrostatics in secondary school, or in A-level physics they are still going to teach you hydrostatics and hydrodynamics. Now hydrostatics is fluid at rest. If you are studying fluid, hydrostatics fluid is fluid at rest, liquid at rest, liquid that is not moving. An example of hydrostatics is when you have your storax, the water inside your storax is what we call hydrostatics pressure. If your water is not moving out, if you have a bucket of water, now the pressure inside that water is what we call hydrostatic pressure, because that water is not moving. So let me explain it. Let's have this diagram that you can all see. Now using this diagram, a liquid is inside this diagram, and that liquid is going to be at a certain height. The liquid is going to possess potential energy, and the pressure at any point here is going to be, if you pick a point, look at my pointer, this point, if you pick it, you see I drew an arrow here. This arrow is showing the height of the liquid inside this container. Now at any point, as I'm going down, the depth is increasing. Now the pressure here will be different from the pressure at this point, so which means pressure is directly proportional to the depth. The lower you go, the higher the pressure. If you punch this, let's say this is a storax, and you punch it here, you punch it here, and water is coming out. Now the distance, the flow rate of water at this place will be so much compared to this place due to the pressure. Pressure increase with depth. Pressure increase with depth. Pressure increase with depth. Now, using this, if you use Archimedes principle and using Torricelli principle, Torricelli law, now the pressure is going to be density multiplied by the height, density of that fluid multiplied by the height times acceleration due to gravity, which is what? hpg or rho gh. So this is the formula that we are going to use, and if we look at it very well, we see that is the pressure at any point is directly proportional to the depth and density. Now, but there is another option that is close to the answer, but not the answer, which is mass and volume. Now, density is what? Mass over volume. So, mass over volume alone is not sufficient to find the pressure of any fluid at any depth here. So, the answer is depth and density, because density itself includes mass and volume. So, the correct answer is B. Let's move to the next question. A room is heated by means of a charcoal. An occupant of the room standing away from the fire is warmed mainly by, let's look at the option. A, convection and radiation. B, convection. C, radiation. D, conduction. Now I'll go back and read the question again. A room is heated by means of charcoal fire. Let's look at charcoal fire. Charcoal fire is going to bring out, is going to radiate. That means it's going to get color. We all know the color of coal. When coal is being lighted, you see, when coal is burning, charcoal is burning, you see it is red. It's bringing out color. It's showing color, which is what? A radiant energy. Radiation. If you are talking about radiation, you are talking about heat that is generated as a result of what? As a result of the color. When an object is being burnt and the color, the light, the electromagnetic wave that is producing in form of light, the radiant energy that is not electromagnetic wave, the radiant energy that is producing. So, and that radiance is going to be a form of heat transfer that does not require a material medium. Which means if you have a hot metal that is red and you bring it close to you, even if it is not touching you, you are going to feel that heat due to radiant energy known as radiation. Now, if you are inside a room and you are using charcoal, air will be blowing. The winds, the air around that charcoal will be warm, will be heated, and as a result of that, they will have low density, and those air will move away. New air will come and displace those air. New air that is having high density will come and push away the one that is hot. That is what we call convection. So if you are standing away from the fire, you will feel the heat by two methods. Heat will be transferred by two means. We have radiation and convection. So if you pick radiation alone, radiation is not correct, unless if you, in the question they state it that wind is not blowing, air is not going to blow. But if there is air and we are all, and if you are in space, air is present, so which means that the air will also be heated. So that means we have convection and radiation is the correct answer, A. Now the characteristics of a vibration that determines its intensity is A, frequency, B, wavelength, C, amplitude, and D, velocity. We are talking about vibration here. And vibration, and we know that in vibration, something is common in vibration. Vibration produces sound. So which means we can use sound wave to explain this. Now, the intensity of any vibration of any wave is directly proportional to the amplitude. Directly proportional to what? Amplitude, not frequency. Directly proportional to what? Amplitude, the intensity. Now let's use sound. The intensity of sound is directly proportional to amplitude. The frequency is directly proportional to the pitch. Yes, is pitch. Frequency determines the pitch. Any sound that is having high pitch, it has high frequency. low pitch, low frequency. So amplitude is meant for intensity of vibration, intensity of sound or any wave, or vibration of any wave. It also determines the energy, because intensity is energy per unit area. Energy of a wave per unit area. That's what we call intensity. The next question, 68. A throw 12.0 centimeter deep is filled with water of refractive index 4/3. By how much would a coin at the bottom of the throw appear to be displaced when viewed vertically from above the water surface? And I have an interesting explanation for this. Let's look at the concept of refraction. Let's have the diagram. Now look at this diagram very well. If you have a container, this is a container here, this is a container, and that container, it contains water. Now we can see that we have water here. The water is filled to the brim according to this diagram, and you have an object placed inside that container. Let's say we have a transparent container containing water, and you have a coin or something at the base here. Now because water is having its own refractive index, and the refractive index of air is 1. So if air is moving, if ray of light is coming, image of object, àwòrán, let me use Yoruba because I believe some of you will understand Yoruba. The image, àwòrán. Now image is formed as a result of what? Intersection of what? Of rays of light. Image will be formed. Now which means rays of light will form image, and image will be formed due to what? The reflection coming from the rays coming from an object. Now since this object is inside another material, it's another medium, which is water, the ray of light for viewing this object, when it is coming out, is going to be what? Is going to be refracted, which means it's going to bend. Now but if you want to now look at this object outside, you want to look at this object, as you are trying to look at the object, there will be an apparent image, which is not unrealistic image, will be formed. This is the apparent image. It will look as if you are looking that is your ray that is forming the image will be undeviated. That's apparent, but naturally the one that is coming from this guy is deviated. Now your eye is now going to form an apparent image of that object, and that apparent image is going to be a little bit or above the original object. So we now have what? The real object, and then what we have apparent, the real object and apparent image of that object will be formed. So now, which means that the height of that object, the apparent image that will be formed, will be proportional to the refractive index of the medium. So that's just the principle. Now we now have what? The apparent depth, the depth at which you are seeing the object, and the real depth. So let's use that concept to solve this question. And let's look at solution. Given that in the question we are given that, that's our diagram again, we know the real depth of the throw in the question, which is, let me go back to the question. This is the throw here, 12.0 centimeter deep, and then they gave us the refractive index, and they have asked us to find the displacement when viewed vertically from above the water. So which means we want to find the apparent depth. Now they gave us the real depth 12.0 centimeter, and then we know the refractive index 4/3. We all know that refractive index for stuffs like this is equal to what? Real depth over apparent depth. But don't forget that if you are talking about the image form, the refraction, we can use real depth over apparent depth. We can also use another formula, which is sine of angle of incidence to the sine of angle of refraction. But that's not what we are using here. That one is Nernst's law. So we are using real depth over apparent depth to solve this question. Now we know that our refractive index is 4/3, The real depth is 12. Apparent depth is what? We don't know it. That's what we have in this place. That's what we have in that place. Now let's move forward. If you cross multiply, you are going to get 4 times apparent depth. 4 times apparent depth is equals to 3 times 12. Now, making apparent depth subject of formula, you divide both sides by what? By 4. That's what we have here. Now, 3 times 4 divided by 12. 12 divided by 4, we have 3. 3 times 3 is 9. So our answer is what? 9 centimeters. Question like this, you're supposed to solve it within 10 seconds. It's very cheap. It's due to explanation that I'm taking time to explain it. The actual time for solving this question shouldn't be more than 10 seconds or 15 seconds. And let's move to the next question. The electrochemical equivalence of platinum is 5.0 times 10 raised to power minus 7 kilogram per coulombs to plate out 1.0 kilogram of platinum. A current of 100 amp must be passed through an appropriate vessel for, let's look at our option, 200,000 seconds, 20,000 seconds, 2,000 seconds, 200 seconds. This one is also a cheap question. So which means they are asking us to find the time of application of the current. So let's look at how to solve it. Solution. In the question, let's go back. They gave us the electrochemical equivalence, which is Z. We have it here, our Z here. They gave us the mass to be played out, which is what? The mass deposited at the anode. Don't forget, this is electrolysis, electroplating. Now 1.0 is the mass that will be deposited. We are given the current, which is what? 100 amp, and they ask us to find time. Which principle are we going to use? We are going to use Faraday's law, first law of electrolysis. And Faraday's first law of electrolysis states that the mass of substance or metals deposited at the electrode is directly proportional to the quantity of electricity that passes through the electrolyte. So that's what we have here. Mass is directly proportional to what? Quantity of electricity. That's IT. Q. Mass is directly proportional to Q. If you change it to mathematics, which is what? M is equals to, you are going to introduce a constant, and that constant is Z. ZIT. So that's what we have here. So we are using Faraday's first law of electrolysis to solve that simple question. Now in the question, they asked us to find time, right? So we know that mass is equals to Z times I times T. So let's go ahead and make times out of formula. Divide both sides by Zi. So your time is going to be what? M over Zi. Now substitute the value. We are given the mass. Everything is already in SI units. So that means our mass is 1 divided by, what is our Z? 5.0 times 10 raised to the power minus 7. What is our T? Time. Our I, current, which is 100. So if you solve this, 10 raised to the power minus 7 times 100. This 100 has 2 zeros. So you are going to subtract it from 7. So that makes it what? 5.0 times 10 raised to the power minus 5. 1 divided by 5.0 or 5, we get 0.2. 1 over 10 raised to the power minus 5, you get 10 raised to the power 5. 10 raised to the power 5 times 0.2, you get 2.0 times 10 raised to the power 4. So it's a mistake here. 2.0 times 10 raised to the power 4, not 5. So 2.0 times 10 raised to the power 4 is also what? 20000 seconds. 2000 seconds. Okay, these are our seconds. So 20,000 seconds. So let's go back to the question and pick the correct answer. B, 20,000 seconds. So let's move ahead. The number 70 question. A man hears his echo from a nearby hill 2 seconds after he shouted. If the frequency of his voice is 260 Hz and the wavelength is 1.29 meter, how far away is the hill? You can read the question again. A man hears his echo from a nearby hill 2 seconds after he shouted. If the frequency of his voice is 260 Hz and the wavelength is 1.29 meter, how far away is the hill? An interesting question. Let me explain the principle. Let me explain the principle before solving the question. Now this is the diagram here, and this is the source where the man is producing that sound. He makes a noise, let's say in the forest. Now what is an echo? An echo is a sound that is heard after a sound, another sound, a sound reflected when it hits an hard surface. So if you produce a sound and you are able to hear back your sound, it's due to what? Reflection of your sound on hard surface. So when the sound wave is coming out and it's encounter a hard surface, there will be a reflection of that sound. So this is the sound direction. A sound is being produced and it's moving forward and it hits a hard surface. That sound will travels back, and the reflection of that sound is what we call echo. Reflection of sound is what we call echo. Now if you look at the diagram very well, you see that the sound is traveling a distance until it hits an obstacle. Now that sound is going to travel back. So which means that when that man produces that sound and is able to hear back a sound, that sound has traveled to and fro. So to and fro, that means what? The distance. It has traveled, it has covered that distance between between the surface and the source. So it's going to go S in the first direction and travel back S, making 2S. So let's go. We are given the time in the question, 2 seconds. The frequency, which is what? 260 Hz, and the wavelength of that sound 1.29 and the 29 meter, and they asked us to find the distance. Now we all know that velocity from law of motion is equals to displacement over time. Now with my explanation here, we know that the sound was able to travel twice to and fro. So the displacement will be what? 2 times the distance over time. And we also know that velocity of a wave, v from wave, is equals to f lambda. Frequency of a wave times wavelength of a wave. Velocity is equals to what? F lambda. V is equals to f lambda. Now since we know that we now have two formulas for velocity, v is equals to f lambda, and v is equals to what? 2s over t. So which means we can equate the two formula. Equating the two formula, we get what? F lambda, which is what? The velocity, is still the same thing as what? 2s over t. That's what we are going to use to solve the question. Now make s solid of formula, which means t will meet f lambda here. T will meet f lambda, and then you divide both sides by 2. You have s is equal to what? ft lambda over 2. Now put your values. What is our f? 260. What is our t? Our time is 2 seconds. What is our wavelength? Lambda 1.29 divided by 2. Now if you solve everything here, if you solve it, you can use your hand to solve it too, or you use your calculator. So you get 335.4 meter. Very straightforward and simple question. So the next question, 71. A perfect emitter or absorber of radiant energy is A. I believe you all know this question. A, you know the answer. A, white body. B, red body. C, black body. D, conductor. The answer is black body. Black body is a perfect emitter or absorber of radiant energy. So if you wear black in, let's say, in warm period, you are going to feel warmer. You are going to, because black used to absorb all the radiant energy. If you shine light, if you shine any color, let's say you have torchlight and you shine it and you just shine the light on black, black is going to absorb all the spectrum in light, so it's a good absorber of radiant energy, and it's also a good perfect emitter of a radiant energy. 72. A radioactive isotope has a decay constant of 10 raised to the power minus 5 per second. Calculate its half-life. Another simple question and straightforward question. So this is coming from radioactivity under nuclear physics and under nuclear chemistry. And let's see how to solve the solution. We are given decay constant. Decay constant is lambda. That's the symbol for decay constant. Lambda, and that's 10 raised to the power minus 5 per second. Now, half-life. Let me explain half-life. Half-life is the time taken for half of a radioactive substance to disintegrate. So if the mass of a radioactive substance is 100 kilogram, the time taken for it to disintegrate 50 kilogram, so which means the time taken for it to become 50 kilogram, is called half-life. So half-life can take place in steps. So we can have the first half-life, the second half-life, the third half-life. So which means that if the half-life of something is 2 days and the mass of that thing is 20 kilogram, after 2 days, 10 mass will have been gone. Then after another 2 days, it remains 10. 5 out of the 10 will have been gone. So that is what we call half-life. Now there is a general formula for it. The formula is derived using calculus. The formula is derived using integration and differentiation. So I'm not going to derive any formula for you guys. So I will just go ahead and show you the formula. Half-life T, half is equals to 0.693 divided by lambda. 0.693 is not a constant, it's derived from, if you solve your formula, that formula that I talked about, just get this formula. 0.693 divided by 10 raised to the power minus 5. And if you do that, we are getting this guy over here, 6.93 times 10 raised to the power minus 5 seconds. So let's go ahead and pick our answer. 6.93 times 10 raised to the power minus 5 seconds. So our answer is. And let's look at number 73 question. The question says, two inductor of inductances 4 Henry and 8 Henry are arranged in series and a current of 10 amp is passed through them. What is the energy stored in them? Let's look at the option. A, 500 joules, B, 600 joules, C, 300 joules, and D, 250 joules. So let's see how to solve the question. Solution. Now let's write out our parameters. And before our parameters, let's look at the diagram. Now this is our parameter. They gave us in the question, we have two inductors. They are arranged in series. That is what we have in the diagram here. We can all see that we have, this is the first inductor here. This symbol is used for inductor. Now this one is another inductor. They are all connected together in series arrangement, both to both. Now the current that is passing through them, according to the question, is 10 amps. The reason why I drew the diagram is they can draw a diagram and ask you to solve it. So you must understand the diagram as well. It's not all the time that they will be writing something for you in electricity. They can just draw the diagram and ask you a question. So, and the question is, we have a voltage supply and we have 10 amp. So the question is now asking us to find what? The current, the energy stored in an inductor. Energy stored in an inductor. Don't forget, inductor is a device that stores electric charges in magnetic field. So inductor is only interested in one guy. Inductor is interested in current. Have it at the back of your mind. Capacitor is interested in voltage, while inductor is interested in current. That is why inductor will slow down current, while capacitor will slow down voltage. Whenever we have the supply of electricity, or let's say supply of electricity, flow of charge, two things are involved. We have the potential difference voltage. We have the rate at which energy is being transferred. That means rate of flow of charges, which is current. So let's go. The formula to calculate. Now let's look at the effective inductance. Effective inductance. Inductor in series is still the same thing as when you arrange your resistor in series. Capacitor is different. Now for inductor in series, you add their inductance. So we have L1 plus L2. The effective inductance here, I'm supposed to draw a single diagram. That means 4 plus 8, that will give us what? Another diagram. 4 plus 8, that will give us 12. So we have 12 Henry. That is the effective, the total inductance. Now energy stored in an inductor, the formula is 1 over 2 Li squared. Last year, just this simple formula, they asked students last year, Jamb asked students. So expect formula. You might not even solve any question in your Jamb this year. You might not solve many questions. You will surely solve question, but formula, they will surely bring out formula. So energy stored in inductor is 1 over 2 Li squared. Now applying that, your L is inductance, I is the current. That will give us 1 over 2 times total inductance, 12 times current, that's 10 squared. 10 squared is what? 100. 12 divided by 2, that's 6. 10 times 10, 100. 6 times 10, 600. What's the unit of energy? Joules. So now let me show you another thing here. The final answer is 600 joules. Energy stored in capacitor. You see, the formula is similar. I've already said it that capacitor is using voltage, inductor is using current. So the energy stored in capacitor is also 1 over 2 CV squared. Don't forget that Q is equals to CV. We have 3 formula for this guy. Have it at the back of your mind that the quantity of charges, the stored capacitance, the capacitance is equals to charge over voltage. Sorry, your capacitance is equals to Q is equals to CV. So your capacitance is equals to charge over voltage. If you supply this, what I just explained, if you supply it in this formula, you see that this formula has 3. We have another 2 various versions of this formula. Energy stored in capacitor is 1 over 2 CV squared. It's also 1 over 2 QV. So let's move to the next question. 74. The electrical properties of germanium can be altered by addition of impurities. This process is referred to as A. Saturation, B. Doping, C. Amplification, D. Bonding. We have a pure germanium. If you want to alter the electrical properties, which means maybe you want to increase the conductivity of a semiconductor, there is a process which is known as what? Doping. Doping is a process of adding impurities to a pure semiconductor. It can be a silicon, it can be a germanium, and when you dope it, the process is known as doping. Let me show you. I think I have some explanation here. And let's look at semiconductor. What is a semiconductor? Semiconductor is their elements. We can call them elements or materials that are in between a melter and non-melter. So in your periodic table in chemistry, semiconductor should be in the same group with carbon. So you don't know, maybe they are melters or non-melter. That's why we find them under metallurgy. So, and semiconductor has various types, just 2. Now we have intrinsic semiconductor and extrinsic semiconductor. Now intrinsic semiconductor is a pure semiconductor. Any semiconductor that you have not added impurities to it, we have intrinsic pure semiconductor. So example of pure semiconductor is just a silicon and germanium. They are pure. In their pure form, they are known as intrinsic semiconductor. Now we have another type, which is extrinsic semiconductor. Extrinsic semiconductor is a semiconductor that you have added impurities to it. You have doped it. You have added a dopant. So which means you have altered the electrical properties. And this extrinsic semiconductor, we can have p-type semiconductor and n-type semiconductor. P-type semiconductor known as positive type semiconductor. N-type semiconductor, we have what? Negative type semiconductor. Now in semiconductor, why are we calling it semiconductor? They can conduct electricity at a certain condition, and they can choose not to conduct electricity. Now, how are they conducting electricity? They are conducting electricity through two different things. They can conduct electricity via electron or via O. Let me explain that. We all know that electron is negative. Now, what is that O? When electron is leaving a space, is moving out, is going to leave a vacuum, and that vacuum is known as O. O is positive, electron is negative. O is positive in semiconductor, is a vacant. When electron leave a semiconductor, it's going to create a vacuum known as O. That O is positive, electron is negative. No, so semiconductor can now conduct electricity via O or electron. So when we have excess O more than electron, we have p-type semiconductor. So which means that p-type semiconductor has the majority carrier in p-type semiconductor is O. Minority carrier, what is small, is electron. Now, if you now want to dope this guy, there are some elements that you need to consider. That element must be willing to accept electron. That is why I call it electron acceptor. So the dopants that you are going to use are going to be pentavalent, which means they have 5 electrons in the atomos shell, and they must be non-metal. It's only non-metal that is willing to accept electron. So electron acceptor, example nitrogen and phosphorus. So to dope p-type semiconductor, you use pentavalent electron donor, example nitrogen and phosphorus. And let's move to n-type semiconductor, negative type semiconductor. Negative type semiconductor has excess electron more than O. So the majority carrier will be electron, minority carrier will be O. Now, if you want to dope them, you want to increase the number of electron for this guy, you must add elements, impurities that is willing to donate electron. For this one, you must add impurity that is willing to accept electron, so that you will create more vacuum. Now let's go for n-type. We call them electron donor. And the dopants, the elements that you're going to use, they are known as trivalent, group 3 elements. Example, aluminium, indium, boron, antimony, and arsenic. You can go and look at your periodic table for more examples, for more elements under group, pentavalent elements under group 5, so that you add them with this. So for n-type, you dope it with what? Aluminium, indium, boron, antimony, arsenic, and they are known as trivalent electron donor. So our answer is doping. Here, doping. So let's move to the next question. The production of hydrogen bubbles in a cell is called dash, and it can be prevented by dash. Now, if you have a simple cell, there are two defects of a simple cell. The two defects is we have local action and polarization. Local action and polarization. Local action is when your electrode is dissolved in the electrolyte. When you have a gradual dissolution of your electrolyte, of your electrode in your electrolyte. So that can be prevented when you coat your electrode with mercury. The process of coating electrode with mercury, coating another metal with mercury, is what we know as amalgamation. So local action, to prevent local action, we use what is called amalgamation process. Now, the second one, which is known as polarization, another defect of a simple cell, polarization. Polarization is when your electrolyte starts producing hydrogen bubbles, and you have hydrogen bubbles coming up. All these things is going to affect the voltage of your cell. So in order to prevent polarization is the production of hydrogen bubbles. To prevent that, we use a depolarizer. An example of a depolarizer is manganese 4 oxide, MnO2, manganese 4 oxide. So the answer here is, since it's hydrogen bubbles, it is what? In a machine of velocity ratio 6, a machine of velocity ratio 6 requires an effort of 400 Newton to raise a load of 800 Newton through 1 meter. Find the efficiency of the machine. Find the efficiency of the machine. In order to solve that, let's look at our parameters. The first one, they gave us the velocity ratio, which is 6, and then we are given the effort, which is 400 Newton. The same thing with the load, which is 800 Newton. And according to the question, the load is being moved, is raised through 1 meter. So the distance is 1 meter. To find the efficiency of any simple machine, efficiency is mechanical advantage over velocity ratio times 100%. It's also work output over work input times 100%. Now here we are going to use mechanical advantage over velocity ratio times 100%. Now what is efficiency of machine? Efficiency of machine is coming from the fact that you have an input energy, an input force into a machine. How much of the force is that machine converting and using it to do the work? That's the concept of efficiency. Let me quickly explain this. Simple machine has a moving part, and the moving part is going to do, you are going to supply a work to it, and out of the work, the moving part is going to use some of it to overcome friction. So which means if you are supplying 100 Newton as the input energy, an input force to a machine, and that machine is now using out of the 100 Newton to overcome friction before using the others to do the work. So it means that that machine is not 100% efficiency. There is no machine that is 100% efficiency due to the fact that out of the input force, some of it will be used to overcome friction. So that's the concept of efficiency. Efficiency is different from mechanical advantage. Mechanical advantage is different from efficiency of machine. Efficiency is just talking about, okay, you are applying this force. How much of this force is coming out in order to do the work? Now, mechanical advantage is load over effort. What is the load in the question? 800. And what is the effort? 400. So if you divide the two guys together, we get 2 for our mechanical advantage. Now in the question, we already given velocity ratio. So let's go ahead and solve it. Our velocity ratio is 6 and the mechanical advantage is 2. 2 over 6 times 100%. That's 33.33%. Simple and straightforward question. Question like this, they are bonus for your exam, so I didn't expect you to miss this type of question. 78. In the alternating current circuit at resonance, the angle of lead or lag is A 90 degree, B pi over 2, C 0 degree, and D minus pi. The answer is 0 degree. Let me explain. For simple AC circuit, I have some things that I've jotted here. We have R circuits. R circuit means current and voltage. We have voltage, we have resistor alone. In R circuit, for simple AC circuit, it is called resistance alone circuit. You only have resistor alone. Now, current and voltage are going to be in phase. So which means that current is not leading nor lagging. It means that current and voltage will not lead each other. They will be traveling at the same pace. Current is not leading, voltage is not leading, voltage is not lagging, and current is not lagging. They are not lagging nor leading each other for R circuit. Now for RL circuit means resistor and inductor circuit. When you have them combined, when you combine them together in series. Don't forget, I've solved a question earlier on that I talked about inductor. That is, inductor is using current. Inductor is using current. Capacitor is using voltage. That same current concept is what brought about this. Now, since inductor is using current, so inductor is going to slow down the current so that voltage will lead current. So current will now lag behind voltage by 90 degree. 90 degree is still the same thing as what? Pi over 2, because pi is 180 degree in radian. And pi over 2 is still the same thing as what? 1 over 4 circle. Because 2 pi is cos to 360, is a complete circle. Now 2 pi divided by 4 will give you pi over 2. So 1 over 4 circle or revolution. So voltage is leading current in RL circuit, or current is lagging behind voltage by 90 degree. Please get this. This question used to come out almost every year they used to ask all these things that I'm explaining now. Now for RC circuit, resistor and capacitor circuit, current, since capacitor is using voltage, so current is now going to lead while voltage is going to lag by 90 degrees. Now at resonance occur when we have in RLC circuit. Don't let me, I'm missing things here. In RLC circuit, we have resistor, inductor, and capacitor. Current and voltage are going to be out of phase. Here, current and voltage are in phase, and no one is leading or lagging. Current and voltage are in phase here. Current and voltage are in phase here, which means that we can draw a single graph to show the direction of this guy. Current and voltage here. A single graph for this as well, but you can't draw a single graph for current and voltage here because they are not in the same phase. They are out of phase for RS circuit. Current is not leading, voltage you can't say maybe it's leading or lagging because they are out of phase. Now at resonance, there's something we call resonance. Resonance occur in RLC circuit when capacitive reactance is equals to inductive reactance. That's what I've written here. 2 pi FL is equals to 1 over 2 pi FC. Now omega is equals to 2 pi F, which equals to 1 over root LC. This formula used to come out. They won't ask you any question. They will just ask you what is the resonance frequency of RLC circuit. They will just write some option. So if I were you, I'm going to screenshot this and write it down. Screenshot it and write it down. Let's look at, we still have the same question for 79. For 80, in comparing human eye with camera, the film of the camera function as there is comparison between camera and human eye. Camera has a lens, our eye also has lens. Camera has where the image is formed. It has a film, and our eyes also has a retina where the image is formed. Camera has a diaphragm. Our eyes also has iris. So there is a lot of comparison between camera and human eye. So here the comparison goes with, the answer is in human eye, the film of the camera where the image will be formed function as the retina. I have another question here. It's supposed to be 81. I have it as 80 here. Thank God there are some questions I made mistake in the typing, so this one will compensate for that. And please listen attentively to this question, the last question. A convex lens has a focal length of 10 cm. An object is placed 15 cm in front of the lens. What is the image distance and the nature? Read the question again. A convex lens has a focal length of 10 cm. An object is placed 15 cm in front of the lens. What is the distance and the nature of the image? That's what they are asking. I'm not interested in the option yet. Let me explain some stuff to you guys. This is very important for your Jamb and even your WAEC if you are writing WAEC or NECO. Convex lens. Another name for convex lens is converging lens. Don't mix it with concave convex mirror. Convex mirror is diverging mirror, while convex lens is converging mirror. They are different. Convex lens is going to converge rays of light. Convex mirror is going to diverge rays of light. That's the difference. Now we can know the nature of any image that is formed by convex lens by knowing the location with respect to some terms, with respect to focal length of that lens and center of curvature. Now the first thing here is, if an object is at infinity, example, you want to use convex lens to form the image of a moon. You know, if moon is so far, or star, is they are at infinity, so far, so the ray is coming from a very far distance. The image will be formed at the focus. This is the diagram here. showing that image will be formed at what? As the focus. And we can see that our image is turned upside down, which means that image will be so small, highly diminished. It's going to be real. What is real image? Real image is formed when we have actual intersection of rays of light. I think I've explained it in a question. Now the image will be real, will be small, diminished, highly diminished, and it's going to be inverted. Odorikodo. It's going to turn upside down when an object is placed at infinity. The same thing goes with converging mirror. Now let's go. When an image is placed beyond the center of curvature, here to here is known as focal length. Here to here is known as center of curvature, and center of curvature is 2 times focal length. That's why I have it here. Now when an image is placed beyond it, it's not too far away from your center of curvature. It's placed beyond, it's not coming from. Now look at the diagram. This diagram is drawn and it's very accurate. I use my system to draw it. Now for this guy, the image, this is the object. You want to use it to form an image. The image will be formed in between focal length and center of curvature. Please, I've sent this to the group. Again, master this. These are bonus questions. When the image is beyond center of curvature, as the object is beyond center of curvature, the image will be formed in between focal length and center of curvature. That's what I've written here. The image will be small, diminished. You can see, look at the object, so big. Look at the image, so small, and it is inverted. And there is intersection of the rays of light. So which means that they are real and inverted. Now let's look at this next one. When an image is placed at the center of curvature, at the other side, you see that all the image that is formed at the other side, when an object is placed at the center of curvature, all the image that I'm showing you are being formed at the right side. Now for this one as well, it's also formed at the right hand side, and it's formed at the center of curvature. So when any object placed at the center of curvature, the same thing goes with converging mirror. The diagram is different. Converging mirror, it is going to be formed here under this one. Why? For lens, the image is formed at the other side. Now when the object is placed at the center of curvature, the image is formed at the center of curvature, same size, and it is real, and it is also inverted. The next one, when an image is placed in between center of curvature and when an object is placed in between center of curvature and focal length, the object will be formed beyond center of curvature and is going to be magnified. Omatobisi. Magnified is real. Omadorikodo, inverted. The image is beyond C, center of curvature, when object is placed in between center of curvature and focal length. Now when the image is placed at the focal length, now look at my diagram. The object, when an object is placed at the focal length, the image will be formed at infinity. Look at it, at infinity, because we won't have actual intersection of the rays of light. Now, but we can assume that the rays of light intersect when that image is formed at the infinity. So that is why we have real here. So image at infinity, the image will be so big and it will also be what? Inverted. You can see it inverted. The next one, when image is placed between center of curvature and focal length, we are going to have a magnified. When object is in between focal length and the pole, when an object is in between focal length and the pole, the image will be magnified, and the image will be what? Magnified. The image will also be in between what? Center of curvature and focal length. In between center of curvature and focal length, it will be erect, not inverted. It will be virtual because we don't have intersection of the rays of light. What we just did here, you can see this dotted line. Yes, I trace it backward. It's not actual intersection. I just trace it backward to form this image. So magnified, erect, and the image is also what? Virtual. And look at it though, the image is still on the same side with what? At the same side with the object. That is the nature of image formed by convex lens. Now we can see from the question that the focal length is 10 cm and an object is placed 15 cm in front of the lens. It means that this 15 cm is more than the focal length. So which means that it is in between the object is in between the focal length and the center of curvature. So let's solve our question first before we talk about the nature of the image. Focal length is f 10 cm, object distance is 15 cm. Then the image C distance, which they asked us, we don't know it, v or no. Using lens formula, it's still the same thing as mirror's formula. 1 over f is equal to 1 over u plus 1 over v. And for convex lens, the focal length is positive. So we have 1 over 10 is equal to 1 over 15 plus 1 over v. Solving this, we have 1 over v is equal to 1 over 10 minus 1 over 15. So if you solve it, you get 3 minus 2, 1 over 30, and 1 over v is equal to 1 over 30. V will be automatically 30 cm. Just look at this question and solve it yourself. V is 30 cm. 30 cm is not sufficient for us enough to pick the correct answer. So let's go back. Now this is the diagram that illustrates the question. Now here to here 15 cm. Here to here 15 cm where the object is placed. Now here to here according to question is 10 cm, the focal length. Here is the 2C. Now if you trace the path, you see that the object will be here, the image will be formed here at the other side, and the image is turned upside down. The distance between here and here will also be what? 15 cm here to here, and here to here is 15 cm, making 30 cm. The 30 that we have gotten the other time. And let's look at the image that is formed. Inverted, magnified, and it is real. Magnify, real, and inverted. You don't need to draw this diagram. The explanation I made earlier on, just the knowledge. When an object is placed in between center of curvature and focal length, this is what I've written there. The image will be what? Magnify, real, and inverted. Just use your formula to solve the question. You get 30, and then you pick the correct answer. So let's go ahead and pick the correct answer. We have 30 cm. The image is magnified, inverted, and the image is real. Alright, thank you for watching this video, and I will join you to study very hard and prepare for your exam as well. I've stated a lot of law. I've explained a detailed explanation concerning so many principles in physics. The first 4 topics for your chemistry, first 4 topics in your chemistry, first 4 topics for your physics in your textbook. The same thing with biology. If you master them very well, be rest assured that you already have 30 marks in your Jamb. If you master them very well, even if you don't know anything, 30 marks is waiting for your exam. I wish you success in your exam. Thank you very much. And don't forget to subscribe to my YouTube channel and share, like, share, and comment on my videos. I have videos on heat energy, on matrices as well, so you can go and watch it. I'll still release some videos for A-level students, 100 level students. As time goes on, I'm going to release some videos. Thank you.